Aloha, Richard Halverson here. This is ITS128, and it is October 1st. Let me share my screen. And so we are in this time period right in between here. We're actually going to finish up 4.20 today, and then I'm going to dive right into loops. So let's real quick do that. I'm going to make sure that that's what I was really going to do, because sometimes I've even given lectures twice before, because before I had the habit of having a playlist and putting the videos up there immediately when I'm done. There's been more than once when I've actually lost track and I did a lecture twice, and I'm sitting and giving a lecture. I'm thinking, geez, this sounds so familiar. It's like I just taught it yesterday. But anyway, yeah, 419. So let's go to let's go to our book and check out 420. So it'd be 420 golf scores. Let's see. I've got a little. I got my notes here. I like to at least acknowledge the way that they do it, or that they say is the, I guess, preferred way of doing it. So let's see. We were down here. Golf scores. Okay. So anyway, let's see what this golf scores record the number of strokes used to get the ball. Yeah, get the ball in the hole. The expected number of strokes varies from hole to hole and is called par. So this is like the expected number of strokes to get to the hole can be either like 3 strokes or 4. That's par. And each score's name is based on the actual strokes. Okay, so if you make it to the hole 2 strokes less than par, you get an eagle. If it's 1 stroke less than par, you get what's called a birdie, or what you did is called a birdie. If you actually get it right on par, what you did was par. So that's par. And if you do par for the course, that means did what was expected. Good job in what was expected. And a bogey is if it takes you 1 more than par. Okay, so you don't want to have too many bogeys. You probably heard those terms before, and now you know where they came from. All right, so given 2 integers, they represent both par and the number of strokes. Write a program for the appropriate score. Okay, so in other words, if the input, yeah, okay, so if this is par and this is how many strokes it took, then it's going to output that. Oh, geez. Okay, so I guess first we have to read in par. First we read in par, then we read in the number of strokes. Okay, so all right, so par. What's par? Par is I'm gonna input par, enter, but I don't want to do this because I'm gonna use this. I'm just gonna use this this thing. I'm not gonna. So when you use this thing, it doesn't look well. I'll leave that there, and you'll see what it looks like as we develop. So enter par. And oh, I want that to be an integer, so I'm going to put the int right here. And then I want to enter the number of strokes that it took. Strokes. Integer input. Enter number of strokes. And so then I want to I'm supposed to say if there's an error, right? Okay, error if it's not 3, 4, 5. Okay, so par has got to be 3, 4, or 5. Okay. If par not in 3 or 4 or 5, then print error. Else, and I can just do this here. If yeah, that's one way of doing it. Okay, well, there's lots of ways of doing it. This is one way. I'm going to do it just a different way. So then I'm going to do else, and I'm not going to care how much I nest my if statements. Okay, so I'm just going to nest these buggers. Okay, so if we're here, then that means we have a legal par value. Now let's say that par is equal to 3. So if par is equal to 3, then if strokes is equal to 2, then print birdie. No. Yeah. Strokes is equal to 1. Print eagle. LF strokes equals 2, print birdie. LF strokes equals 3, print par. And then the last one is bogey, right? And these are the only ones you have to worry about. I guess you don't have to worry about less than eagle or greater than bogey. So I'm just going to say, well, I'm just going to say LF strokes. I'm going to consider the case because it could be something else. Then I'll make sure I get these colons right. Print bogey. Did I spell bogey? Okay, and also I think this should be capitalized. And I'm going to say else print invalid number of strokes. Okay, so this takes care of if par is 3, and then we have to do if par is 4 and par is 5. So I'm gonna make this. So the difference here is the difference between par and strokes is 2. Okay, so and here the difference between par and strokes is 1. Here the difference between par and strokes is nothing. Here the difference, okay, so it's 1. So I'm going to do this instead. If par minus strokes is equal to 2, then this, if par minus strokes equals 1, yeah, that's right. If par minus strokes equals if par equals strokes, and if strokes minus par equals 1. In other words, strokes is 1 bigger than par. Okay, when we do it that way, then we aren't even looking at, then there's no reason to have this. So then we're just like this, and let me select this and bring it back one. And we can actually combine this, can't we? Yeah, we can. We can just combine this. And then bring all this back one. Yeah, this will probably work. So 4 and 3. So if I put, so if the input is, if the number of strokes is, first you put the par. So I'm going to first start by putting 2 for par. Oh, and I have to put a strokes anyway. So it's 2 for par, which it's probably no place says, there's no hole that's par 2, but let's see what happens if I just do this. It's going to say invalid. Wrong. They have to be the same kind of quotes. So let me just, this should say invalid. Okay, it says this because I say to print that out. And then it says this because I say to print that out. And then it goes down and processes it, and it prints that there. So, but anyway, let's try 3 and 2, and 4 and 2. Yeah, that's par going up. Par goes up. So let's do 4 and 4. So that's par, and 4 and 5 is going to be bogey. So anyway, you can fix this up and get that to work. All right, let's start with let's do some of chapter 5 here. Let's see what chapter 5 looks like. Okay, so we're going to learn about a couple of kind of while loops and for loops, and counting, and what range is, what the differences between while and for. And let's see what this one is. Convert to binary. Okay, here you would use a while loop probably. So let's just start with a little lecture here. Okay, so the concept of a loop is that you repeat a section of code multiple times until you stop. And there's various ways that you're going to stop. You have to make sure that you will stop somehow, you know, by your coding, that some condition is going to happen where the looping stops. Otherwise, you're in what's called an infinite loop, and you don't want to be in an infinite loop. So, here's an example of a loop concept where let's say, you know, if you have a baby, sometimes this works where your baby, where if your baby's got gas or whatever, it's crying all the time, you drive the baby around in the car until the baby falls asleep, and then you go home. So here's a loop where you're driving around and you keep on driving, and whenever you come to this point, you check to see if the baby is still awake. If the baby's still awake, then you turn right and you keep on doing this, and the baby's still awake, yes. But if you come here and it's false that the baby's awake, in other words, the baby's asleep, then you can turn left and go back home. See, so that's the concept of a loop. And of course, this assumes that sooner or later the baby will fall asleep, because if the baby never falls asleep, then you're in an infinite loop. All right, so this does an animation. It looks like it does 2 checks and the baby's still crying, but the 3rd check, the baby is asleep. And so you can just test your concept. When the parents first checked, was the baby awake? Yes, the baby was awake. After the first loop, was the baby awake? Yes. And so on. You can figure out exactly when it is when it's not, when the baby is not awake. And so sometimes it can be kind of tricky. Sometimes you can be off by one. You know, you're writing your code, and instead of the second loop, you say it's the third loop because it's the third time, but actually the question is, how many loops does the baby stay awake? And really that's only 2 loops, and you get this off by one thing, and that happens a lot in programming. It's called an off by one error. Off by one errors are very common in programming, and they're always something that you want to look out for. All right, where's the decision point on whether to loop? It's at the top of the street or at the bottom. I guess it's at the top of the street. Top. Yeah. Okay. All right. So in programming, you know, in this example, a simple loop to sum up input values. And so let's say you have a program where you keep on reading input values until you read a -1. And so this will be your signal, your sentinel, the signal that you're done, and you don't want your loop to continue and you're done summing up numbers. So here you'd have the same kind of loop thing, and while, you know, here you grab the first input, and then while that input is greater than -1, you loop, and you notice at the very end of the inside of the loop, it's get the next input, because you have to have a new val, because you're going to test a new val. You don't want to test the same val. If you test the same val all the time, you're in an infinite loop. So you always got to make sure that you're getting the new one. And so each time this executes, it's going to be executing a different value here, you know, in hopes that sooner or later it's the value that causes the loop to stop. In this case, while the loop is greater than -1, or while the loop is 0 or higher, then it continues to add to itself. Okay, so anyway, so that's how that works. Here's an example of computing the average, where, you know, to compute the average, you add up all the numbers and you divide by how many numbers there are. You add up all the numbers and then you divide by how many numbers there are. So this line here adds up all the numbers. Each time there's a new number coming in, you add it to the sum. And this here just counts the number of numbers. Each time you process a new number, you add 1 to this. And then so when you're done, you just divide the sum by the number and you get the average. So let's test your understanding of that. Each time through the loop, the sum variable is increased by the current input value. That's the sum variable. Each time, what was the variable num's value after the loop was done iterating? After the loop is done iterating, it must have been 3. 3. Okay. Anyway, all right. Here's an example of counting specific values in a list. Programs execute one statement at a time, thus using a loop to examine a list, and updating along the way, as in the above examples, is a common task. Below is a task to help a person get accustomed to examining a list of values one at a time. The task asks a person to count the number of negative values, incrementing incrementing the variable to keep going. Okay, so what's supposed to happen is numbers are going to appear. No, I guess I click next value. But if it's a negative number, then I click on increment. If it's not a negative number, I do not click on increment, because I'm just counting. I'm counting negative numbers. Okay, so let's see what happens here. What am I supposed to do? Well, I'm supposed to click next value. Oh, I didn't mean to do that. Anyway, see, it's a race. Reset. Sure, whatever. Okay. Increment, next value, next value, next value. Increment, next value. Increment, next value. Increment, next value, next value. Oh, I got it all green. Very good. All right. So here, complete the program such that the variable count ends by hence having the number of negative values. So this is a program to do that. It's supposed to be this program, and you're supposed to write what statement A, or what goes here and what goes here. And so what this is if the value is less than 0, oh, it goes until it gets to 0. Yeah, okay. If the value is less than 0, this is what A should be. Then you increment something. What is it you increment? You increment count. You increment the count. If the input value is 0, does the loop body execute? No. The loop body executes only when the value is not 0. So, no. All right. Finding the max value. Oh, is this another one of these? Okay. Click store value if the new maximum value is seen. Okay, so I'm going to go along, and whenever I see, and each time I see a new maximum, I'm going to store it. And at the end, I should have, and so this is, you know, here we're going to execute an algorithm to find the largest value in a list by looking at each one at a time. Okay, so I'm going to start and store this value, next value, next value, next value, store that value, next value, store that value, next value, next value, next value. So the only time I stored the value is when the value over here was bigger than the value that I currently had for a max. Anyway, so this is so you start out with an extremely small max, where you know that the first value that you read in is going to be store as a new value. In fact, it could be 0. Yes. But anyway, so if the value that you read in is greater than max, then store that value into max. So if the value is greater than max, then you want to store value into max. What does the final value of max depend on? Depend on the order. Does the final value of max depend on the order of the inputs? No, it does not, because it doesn't matter what the order of the inputs are. This one is going to store the largest one, no matter where it is in the list. It'll grab out the largest one. Okay. Okay, so here we're reading along, and we're seeing what the value of max is each time, or each time it changes. What does max change to? Okay, so the first time max gets set to 5, then max gets set to 10, then max gets set to 20. Okay, so it's this one: 5, 10, 20. This would never happen, because certainly these should always be increasing. Okay, and here it's a max of 10, and then somehow a 7 gets stored in place of the 10. So anyway, it's this one. All right. While loops. A while loop is a construct that repeatedly executes an indented body of code, known as the loop body, as long as the loop's expression is true. At the end of the loop body, the execution goes back to the while loop statement, and the loop expression is evaluated again. If the loop expression is true, the loop body is executed again. But if the expression evaluates to false, then it's not, then it's done. Okay, so here, while this expression is true, do whatever is down here, and then go back and check it again. Okay, so there's got to be something in here that's going to change the expression. That's got to make it different than the last time it tested. So you know, keep that in mind. All right, so here we're gonna so we're gonna read. We have a value here that's stored into this variable called cur power, and we're reading in characters because we start out with a default of y, but each time we read in a character and we go back and test it, blah, 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 read in a new one, test it. And so we do that until the input is an n, is not a y. We do it until the input is not a y. So the first time it loops through, it's because this was set to a y. Then it loops through again because this is a y, then it loops through again because this is a y, and then it reads the n and it doesn't loop again. So that's why there's 3 outputs. Each time it loops, the current power is multiplied by 2, or it's doubled. Current power plus current power. So each time so it doubles and it doubles and it doubles. Starts out at 2, doubles to 4, doubles to 8. Starts out at 2, doubles to 4, and doubles to 8. Two. Okay, and then does this, does that, does that. All right, so anyway, that's that. So for each question, indicate how many times will the loop body execute. So it starts out at 3. So it executes once when it's 3, and then it subtracts 1. Then executes once when it's 2. Then it subtracts 1. Then executes once when it's 1. Then it's done. So I guess it executes 3 times. Yes. Assume the user would enter n and then enter n and then enter y. So get the character from the user. It's n. What's the question? Oh, indicate how many times the loop will. Okay, so n once, n twice. Once, grab this. Twice, grab this. Okay, yeah, so twice. Oh. Oh. Will the loop body ever be entered? Get the character from the user here. The user enters n. Oh, when the character is not equal to n. So the first time the user enters n, so it would never be entered. So I guess the answer is 0. Yeah. All right. trick question. Okay, anyway. You can answer that one. Okay, so here's an example of this while loop that has this, where they use this, and I think I used this term before, this sentinel value. It's a value that it's looking for, that it'll always check for, and that particular value means that, you know, that'll be something that terminates the loop. So here, for example, you're reading a bunch of values. Here you're reading a bunch of values. Enter a character, and you keep on entering characters until you enter a Q, and that's what makes it quit. And so I'm not sure what this does. This makes it face, I guess. This will draw a face, draws two eyes, a nose, and a mouth. And I guess and each time you enter a character for the eye and the mouth, a character to make the eyes and the mouth. So anyway, that's this program does that. Let's see, I'm going to see if it, let me go to that was from before, wasn't it? Let me this is 128. Let me open up test pi. Okay, so test 2 pi in 128. I'm going to copy this. Did I do that already? Copy and go over here, and I'm going to paste it. And I'm going to save it. I'm going to bring up my CMD, and I'm going to say CD desktop, OneDrive desktop ITS128, and there's my test2.py that was created just now. And so I'm going to do Python test2.py, and what happens? Okay, I get that. Oh, now I'm supposed to enter in some characters. Like I can enter in a $sign, and it makes the face using a $sign. I can enter in an asterisk, and enter in this. Whatever. Okay, or if I enter in a Q, what happens if I enter in a capital Q? No, that's not it. It has to be a lowercase q, and it says goodbye. It says goodbye. All right, so anyway, so here it talks about loop expressions. And so here, you know, it's the condition that has to be true for the loop to continue, or the condition that has to be false for the loop to end. And so here, iterate while x is less than 100. Iterate while x is greater than or equal to 0. Iterate while c equals g. Iterate until c equals z. So until means it means that's when to stop. Stop when c equals z. So you want to iterate while c does not equal z. So while c does not equal z, then iterate. Once c equals z, you stop iterating. Stepping through a while loop. Okay, so, ooh, this is a good one. Isn't this just like, this is just like convert to binary, except for here we're converting to, we're figuring out the digits of a number or something. Okay, anyway, so following the animation provides a loop example. The user enters an integer and the loop prints out the digit one at a time, starting with that. Okay, so so this is a fun little exercise where the user enters in a number, and then what you're going to do is you're going to peel off each number one at a time. You're going to peel it off. And so here, the user enters in 902, and you want to print out first the 2, and then the 0, and then the 9, okay? The 2, you print out the 2, and then you print out the 0, and then you want to print out the 9. And the way you do it is you take this number, and you do a mod 10 to get this. And then you take this number, and you divide by 10 to get this. You take this number, you take a mod 10 to get this. And you take this number, and you divide it by 10 to get this. Mod 10 to get this. Divide it by 10 to get this. And then once you're at 0, then you're done. See, and so this is the dividing by 10. So you take the number, and you take the mod 10, and that's actually what you're printing out. And then you take the dividing it by 10, and then that becomes the new number. And then you keep on looping until the number becomes, until this is false. And so it's going to keep on looping while this number is greater than 0. But once it hits 0, and it will, then it stops. All right, so it's 108. Okay, so that's an interesting I'm going to do this lab right now, convert to binary, okay? So let's do this 5.14. Let's see how far. See where I just got to make sure we were. We got to 5.2. We got to. Oh, this is that ancestor one. This is really a weird one. I can't really understand how this one works. But anyway, you can click through that. Here it talks about infinite loops. 1945, what is this supposed to tell me? Okay, so this is user year is enter a past year. So enter 1945, it's this year. And we're going to keep on looping. And each time we loop, we're going to double our number of ancestors. And then we subtract 20 years. So it's going to be 20 years per generation. That's kind of short, but and we're going to start at 2020 and two ancestors per year, let's say, and we're going to go back until we hit this year. And so each time this gets smaller by 20 each time. This is 20. See, no, it's this one, 20. And so each time the ancestors double, so it gets a chance to double 4 times. Looks like, because 1960 minus 4 is 1940, and that's before 1945. So you'll have 16 ancestors. Okay, that's the while loop ending. So we see this causes the Y to change, and it's going to you know, cause the loop to stop looping when it reaches a particular point. See, it's 111. I'll do this convert to binary one at the end of this section. That way I can say I finished this section. All right, so let's do these challenges here. Well, let's see. I'll do one of these here. I'll do this one here. While x is not equal to 3, print x. Okay, so the first time I'm going to print x is 10, and then I'm going to divide it by 2, and I'm going to get 5, and then is x equal to 3? What happens if it never stops? This becomes an infinite loop, because it's never going to equal 3. Each time I divide by 2, so 10 divided by 2 is 5, so it's going to print the 5, and then it's going to come back and it's going to divide by 2, and it's going to equal 2.5, I guess. So this is going to be equal to 2.5. So it skips over 3. So this is going to be an infinite loop. IL. Yes, IL. This one, while it's not true that y is less than x is less than z, let's see, right now, when it starts out, y is not less than x. So this is false, which makes it true. So x is printed. Okay, so y x. Okay, how about x and z? X, when x is less than z, x is less. It's true that this is z. Each time x goes up by 1, so it's going to go up to 2. Well, anyway, this is a brain teaser. You can figure it out. Let's do a challenge activity. While g is less than 1, print, and then add 1 to it. Okay, so it starts out at 0. Is g less than 1? Yes, it is less than 1, so it prints g, and that's going to be 0. And then it adds 1. Oh, it prints that. Then it adds 1 to it. Is g less than or equal to 1? Yes, it is, so it prints that. Then adds 1 to it. And then is g, and then g becomes 2. Is g less than or equal to 1? No, it's not, so we're done. Okay, I got it right. Okay, so you can do that. Basic while loop with user input. Write an expression that executes the loop body as long as the user enters a non-negative number. Okay, so while user num is greater than or equal to 0, then do this. All right, let's do, let's see, is this one? Write a while loop that repeats while the user number is greater than or equal to 1. In each iteration loop, divide the user number by 2, then print the user num. Okay, so we keep on printing the number until user num becomes not greater than or equal to 1. So while user num is while user num is greater than or equal to 1, then you want to print it and divided by 2. Equals user num divided by 2. Now, is that right? Does it automatically just convert to a this one was not printed. See, what I'm confused about is that this is an integer, and then the first time we print it out, it prints out as a floating point number. So I'm going to take this code times an hour to me. Take this code, and I'm going to put it over here, and I'm going to save it, and I'm going to try entering in 10, and what happens? Okay, well, it seems to work, but trouble is the first time it printed out a floating point number. So I don't know. How about if I do how about if I do this? Float. I'm being stupid. Let's see what happens. Oh, oh, I bet you I'm supposed to do something like this. User num equals user num divided by 2. I bet you I'm supposed to do something like that. And then I don't need this. Oh, it didn't print out the last one? Well, it's supposed to print out the last one. All right. So I think I'm going to okay, let me see if this works. Oh, oh no, that's wrong direction. Well, I guess I do want that there. I don't want this there, but I need to print out the last one. Oh, how about if I just do this? There. Oh, that should not produce a result. So All right, how about this, this, and this. There we go. Oh yeah, okay. All right, good. Wow, I just had to flip those around. So this was the right answer. That was the right answer. Okay, anyway, great. So let's do 1.22 here. I mean, no, I mean this one. Okay, so you remember we did the one where we pulled off each integer, a base 10 integer at a time. We pulled them off one at a time. This time we're doing the same thing, except for we're going to be pulling them off. We're going to be doing base 2. So write a program that takes in a positive integer as input and outputs a. Okay, so this is going to take 6, and it's going to print out. You know, 1, 1, 0 is 6. Okay, so it's going to divide by 2. It's going to read in 6. Let's see. So we read in 6. Let's see. Num equals int input whatever it is. Okay, so I'll just use this thing. Then we're going to pull off as long as x is greater than 0. So while num is greater than 0, I might as well use x. Okay, let's just use it. As long as x is greater than 0, output x modulo 2. Okay, print x modulo 2. So it's going to be a 0 or 1 that it prints. Print that. And then assign x equals x divided by 2. And I bet you we got to do this and equals nothing. So I'm going to put 6 here and see what happens. Oh, look at that. Let's see. 1001 is 9. So let's see if 1001 9. Nice. 15 is 1111. Oh yeah. Okay. Well, right. It looks like we got this one. And it is 1:25. Well, I guess we can end a little early today.